Hello students, we are going to study group 2 elements, okay, and these group 2 elements are known as alkaline earth metals. Why they are known as alkaline earth metals? Because they are the metals which are extracted from the earth and they are alkaline in nature. It means they dissolve in water, their oxides dissolve in water to form hydroxides. Okay, so they are known as alkaline earth metals. This group 2 elements, alkaline earth metals, is in S block elements chapter, isn't it? Now, here it consists of the elements beryllium, magnesium, calcium, strontium, barium and radium. When we talk about this radium is radioactive in nature, very reactive, okay? Now, here when we talk about this beryllium, this is the first element of this group 2, isn't it? And it will show the anomalous behavior. Why it will show the anomalous behavior? Because of its small size, isn't it? It doesn't have any vacant d orbitals. Electronegativity value, its positivity value, okay, is entirely different from this. And yes, basically the atomic size is very small, and as the result effective nuclear charge is more, and this gives it a different property. Okay, now when we are seeing about these elements, okay, they will all have what? 2 electrons in its valence shell. It means the valence electrons present in this group 2, okay, elements are 2. Okay, so let us see about the properties. This 2 electrons present in the valence shell gives it the different properties, the physical and the chemical properties. Okay, so when we talk about the atomic size and the ionic radii, what happens in this? As we go down the group, okay, as we go down the group, what do we see? We see the atomic size is going on increasing. Why the atomic size is going on increasing? This is because of the number of shells is going on increasing. In first you can see it only 1, second you can see it is 2, third you can see it is 3. Okay, so these shell numbers are increasing. Okay, and as the result, if the shell number increases, naturally the size, atomic size increases. Okay, now when we see about the effective nuclear charge, the first one will have more effective nuclear charge than the second, because here what is happening? The nucleus is too close. So the effective nuclear charge increases, and as the result we are seeing that the first element has got more effective nuclear charge than the second one. Okay. Now when we talk about the ionization enthalpy, okay, what is first ionization enthalpy? It is the energy required to remove the outermost electrons which is present in the valence shell, isn't it? So when we see about the ionization enthalpy, what happens when we go down the group? Okay, the ionization enthalpy decreases. Why does it decrease? Actually, the size is becoming large. And as the result, what is happening? The effective nuclear charge is becoming less, because the shell is present at a largest distance from the nucleus, and as the result, the effective nuclear charge of this nucleus decreases, and as the result, now the electrons are not held together with a very strong force, and as the result it can be removed easily. So as the shell number goes on increasing, the effective nuclear charge goes on decreasing, and as the result the low ionization enthalpy as we go down the group. Okay, so here this ionization enthalpy I explained to you right now, it is due to the large atomic size, and as the size increases, effective nuclear charge decreases. Okay, now when we talk about this ionization enthalpy, let us compare it with the alkali metals. Okay, alkali metals, okay, naturally they are having what? 1 electron in its valence shell, but this alkaline earth metals, they have 2 electrons in its outermost shell. So now think, which will be easy to remove? Very easily can be removed. The one consisting only of 1 electron in its outermost shell and the valence shell, and that is the alkali metals, isn't it? But this alkaline earth metals, they are having 2. So what happens? Here we are seeing what? This ionization enthalpy of this second group elements are more than the first group. Okay, here you can also see that in the same shell, when we talk about this sodium, okay, this sodium, you are seeing here, in this only one electron is present, isn't it? But when we talk about this magnesium, you will see 2 electrons. Naturally, here effective nuclear charge is more. These are held with more force from the nucleus, but here this electron is held with the less force, because here only one electron is present. Here effective nuclear charge is more. Here effective nuclear charge is less, because here the number of protons are less. Here the number of protons are more. And as a result, these electrons are held with more force rather than this one electron which is present in the alkali metal. So here this electron can be removed easily. And as a result, we are seeing what? That yes, when we compare this, okay, so what we are seeing, that from this alkali metal, here it can be easily taken out as only one electron is present, and that too the effective nuclear charge of that element is less, because less number of protons are present in the nucleus of the atom. But when we go to magnesium, here we are seeing 2 electrons in the same shell, isn't it? Effective nuclear charge more. Here the number of protons have become more. As the result, effective nuclear charge more, holding more tightly the electrons. Okay, so here we are seeing that yes, when we go from this sodium to magnesium, all belongs to the third period only. Okay, when we go from sodium to magnesium, we are seeing that yes, ionization enthalpy is increasing. Okay, but which ionization enthalpy is increasing? The first ionization enthalpy. Okay, because here first ionization enthalpy, here one electron is removed out, but here what happens? It is consisting of 2. More energy required, effective nuclear charge more. But once we are seeing that yes, if this has been removed, now it is consisting of 8 electrons, isn't it? So we all know, to complete the octet, okay, 8 electrons only required. Stable now after giving 1 electron. But here what happens? In this, here also in this second shell, you can see that yes, 8 electrons are present. Okay, but here, once the first one is removed, the second one to remove it becomes easy, because only 1 electron is here, and this can be removed more easily rather than this 8 electrons present in this shell of sodium, isn't it? And so what we see, the first ionization enthalpy in case of alkali metals is less than that of alkaline earth metals. But yes, when we talk about the second ionization enthalpy, we are seeing what? That yes, alkaline earth metals have got low ionization enthalpy than the respective alkali metals. Okay. Now coming to the hydrogen enthalpies. Okay, what happens in this? Actually, it is combining with water. Okay, and hydrogen is taking place with the salts of these elements. Okay, so we are seeing in this hydrogen enthalpy decreases with the increase in ionic size. Okay, so here we are seeing that yes, the hydrogen enthalpy, when we are seeing this is what? Going on increasing with size, but the hydrogen enthalpy is going on decreasing, isn't it? Here we are seeing the least hydrogen enthalpy of this barium 2+ ions than the beryllium 2+ ions, isn't it? So here hydrogen enthalpy, if we compare with the alkali metals also, the hydrogen enthalpy of this alkaline earth metals or the second group metals is more than the first group metals. Okay, now first group is what? The alkaline metals. Okay, so here we can see what? That yes, magnesium, calcium, they are forming easily the hydrates, that may MgCl2.6H2O in case of magnesium, CaCl2.6H2O in case of calcium. Okay, but when this we see it with sodium and potassium, they don't, isn't it? They don't form this hydrates. Okay, so this is the difference between the alkali metals and the alkaline earth metals. Okay, now when we talk about how does they look like, actually these alkaline earth metals, okay, they are silvery white in color. Okay, and they are lustrous, means shiny in nature, okay, and soft, but they are harder than the first group. We have studied that yes, alkali metals are soft in nature. They can be cut with the knife. These are also not too hard in nature, okay, but yes, they are harder than the alkali metals, okay. Now talking about the electropositive character, as we go down the group, its electropositive character increases. Why? Because to give out the electrons it becomes easy, and when we compare it with the alkali metals, we are seeing what here the electropositive character is less. Why the electropositive character is less in case of group 2 rather than group 1? Because in group 1, to remove that one electron, it is very easy. We have studied. So ionization enthalpy, first ionization enthalpy is less in case of alkali metals rather than the alkaline earth metals, naturally making this alkaline earth metals less electropositive in comparison to the element of the alkali metal. Okay. Now coming to the melting and the boiling point, when we see this melting and boiling points, we are seeing what? It will be increased. Why it will be increased? Because here we are seeing that yes, they have got smaller size and 2 valence electrons are present. Small in size, naturally the bond is strong, and if the bond is strong, ionization enthalpy becomes more, and here making it thereby what? Their melting point and boiling point more than that of the first group elements. Okay. When we talk about the conduction of heat and electricity, yes, they do conduct heat and electricity. Okay. Now, if we are doing this flame test for this group 2 elements, okay, so what type of color it will show? When we are talking about beryllium and magnesium, okay, they have got very strong bonds. Naturally, what will happen in this, electrons are packed strongly over here, and naturally they will not show any color in flame, because that flame is not efficient to excite the electrons in this magnesium and beryllium, and as the result we don't see any color. Okay, but when we talk about this calcium, okay, this calcium, strontium and barium, okay, they do. What happens when heat is provided to it? Okay, I said to you, how do we do the flame test? Actually, we take the platinum loop, okay, and yes, this salts of this calcium, strontium or barium, whatever it is, okay, it is mixed with small amount of HCl and then taken in the loop, and on the flame we test the salt by seeing the color. Okay, so here we are seeing what? In this calcium, suppose the salt of calcium is there, naturally when we are taking this salt, okay, in the flame test, what happens? This heat of the flame excites the electrons, okay, and naturally the electrons of this calcium gets excited, and yes, when it tries to come back to its ground state, and here it emits, okay, a radiation of a specific color in the visible region, and that specific color is what? The brick red, okay, color. So calcium will be getting brick red color. Okay, when we talk about this barium, very nice color we see, that of that green apples, okay, and very clear color it comes. When we talk about strontium, it gives crimson color. Okay, now talking about the chemical properties of group 2 elements or alkaline earth metals. Okay, here we are seeing what? When we talk about the chemical properties, okay, here we have talked about what? Physical properties. Simply we have studied with the bonds and all. But when we are talking about the chemical properties, we are seeing how it is reacting with the other substances. Okay, so when this alkali metals reacts with oxygen, and yes, if we do provide heat to it, it forms the oxide, and that oxide is a monooxide. For example, here, suppose if magnesium has been taken, you will be getting what? MgO. Okay, getting? Now, and here you can see it with this lithium. Lithium also forms a monooxide like that of magnesium. Okay, now when this metals, alkaline earth metals reacts with water, okay, what does it give? Suppose here magnesium is reacting with water, okay, it will not react with cold water, okay, it will react with boiling water, hot water, okay, to give what? Magnesium hydroxide plus H2, okay, gas is given out, okay. When calcium is reacting or this strontium is reacting, they easily react with cold water and they give calcium hydroxide, and strontium will give strontium hydroxide, and yes, which gas will be liberated? Hydrogen gas will be liberated out, okay. Now when this alkaline earth metals reacts with halogens, okay, halogens are what? Group 17 elements, fluorine, chlorine, bromine, iodine, okay. It forms the compound that is what? Whatever you have taken, if you have taken Mg, it will be forming what? MgCl2 if chlorine has been taken, okay, if bromine has been taken, then MgBr2, okay. Now when these alkaline earth metals, okay, taking the general formula M, okay, reacting with nitrogen N2, okay, it forms the nitrides having the formula M3N2, where M is the general formula for any alkaline earth metal, magnesium, calcium or any, okay. And yes, when these nitrides are passed or it is reacted with water, they form what? Their corresponding hydroxide, and yes, ammonia is released, okay. So here taking the specific one, let us take calcium, okay, calcium Ca3N2, okay, this is the nitrate of calcium, calcium nitride, okay, reacting with water, giving what? Calcium hydroxide, and yes, ammonia, okay. Now here these alkaline earth metals, now if they react with carbon, they form carbides having the formula MC2, okay, but here there is the exception of beryllium. Beryllium doesn't form carbides, okay, because of its anomalous behavior, okay. So this carbide, you can see when this any carbide, it is of magnesium, calcium, any, okay, magnesium carbide or calcium carbide or any other carbide of alkaline earth metals, okay, they react with what? They react with water. Here we are seeing which reaction is going on. This carbide, any alkaline earth metal carbide, okay, taking a specific example only, magnesium carbide, okay, it reacts with water. Which reaction is taking place? Hydrolysis is taking place, and as the result, what is being formed? Calcium hydroxide, plus you can see that acetylene is formed, okay. Acetylene is what? Ethyl, okay. Now here next, with H2SO4, what reaction does they give the alkaline earth metals? H2SO4 is an acid, isn't it? A strong acid. It will be forming the corresponding sulfates having formula what? MSO4. Like if it is magnesium, it will form MgSO4, okay. Plus what is given out? Hydrogen is given out, okay. Now taking alkaline earth metals again and reacting with a base, strong base, NaOH, okay, taking, okay, here we will be seeing that only beryllium perform this reaction, okay, with this NaOH, and forming what? It is forming sodium berylate, that is what? Na2BeO, okay, this is what? Na2BeO, sodium berylate, okay, plus hydrogen is given out, okay. Now when this alkaline earth metals, okay, they react with hydrogen, here we are seeing that yes, alkaline earth metals has got only 2 electrons in its valence shell, it is also very electropositive in nature, thereby forming what? The corresponding hydride. Like you can see, calcium can form what? Calcium hydride, having this general formula, if we take it is MH2M for any element, yes, specific if we see that is CaH2, okay, and this is known as what? Calcium hydride, yes, commonly we can say as hydrolith, okay. Now this alkaline earth metals, okay, they have got reducing character. Why they have got reducing character? Because they are capable of losing the electron and thereby reducing other elements with which it is acting to form the salt, okay. But when we talk or when we compare it with alkaline earth metals, beta, what happens? It is what? Reducing nature is less than the alkaline earth, than the alkaline metals. Why? the reducing nature of alkaline earth metals is less than that of alkali metals. Why? Because we are seeing that yes, more easily which can give the electron, the alkali metals rather than the alkaline earth metals, isn't it? And yes, here you can see that in this, when it is passed with this alkaline earth metals, okay, reacted with ammonical solution, it gives a clear blue solution, this also. And yes, we are seeing that yes, it is paramagnetic in nature, and as they are having charges, they are also conducting in nature. Now let us study about the general characteristics of the compounds of second group elements. Okay. So let us study about the compounds. If we will be studying about the hydroxides, the oxides, the halides, okay, which they are forming, okay, by combining with the other elements. So first let us study about the oxides. Okay, here for general alkali earth metals, okay, symbol I have taken over here M, okay, O for oxygen. Okay, so general formula is for the oxides of the alkaline earth metals is MO, where M can be magnesium, calcium, Ni, okay, and O for oxygen. If we are talking about magnesium oxide, MgO, okay. Now, when we talk about the stability, they are extremely stable in nature, okay. Here we are seeing that yes, beryllium oxide, okay, this is covalent in nature. Rest of the oxides of this alkaline earth metals are ionic in nature. What do we mean by covalent? It means sharing of electrons is being taking place. What we know by ionic? Transfer electrons are taking place. Again, transfer of electrons are taking place. So here in beryllium oxide we are seeing it is covalent in nature, and yes, the property which it is showing is what? Amphoteric in nature. So what do we mean by this amphoteric oxides? Okay, they can react with acid as well as base to form what? Salt and water. So here beryllium oxide when reacts with HCl, hydrochloric acid. So here beryllium oxide is acting as a base because it is reacting with acid, okay, and forming beryllium chloride plus water. Next reaction we are seeing beryllium oxide plus sodium hydroxide. This beryllium oxide now, as sodium hydroxide is a base, this beryllium oxide is acting as an acid, forming what? Sodium berylate and water, isn't it? This is what? Sodium berylate and water. And others, they are ionic in nature. If they are shows the ionic properties rather than this, and so if they are showing the ionic properties, they are what? Basic in nature. The other oxide like MgO, calcium oxide, they are basic in nature. Metallic oxides are basic in nature. Okay. Now, when we are seeing about this oxides, all the oxides are soluble in water. Okay. Like calcium oxide soluble in water, forming what? Calcium hydroxide. But yes, there is exception of beryllium oxide and magnesium oxide due to their properties. Okay. Now, coming to the hydroxide. So, the general formula, if we are seeing, if we talk about calcium hydroxide, CaOH whole twice, magnesium hydroxide, MgOH whole twice. Okay. So, the general formula if we take for alkaline earth metals M and OH whole twice. Okay. Now, when we are seeing about the hydroxides, they are basic in nature, you all know, isn't it? Except what? Beryllium hydroxide. Again I am saying this is amphoteric in nature because if it can react with acid as well as base to form salt and water. Okay. This hydroxide, when we are seeing in this, here we see about the basic nature. Okay. So basic nature, if we go down the group, it increases. Why does it increase actually? Because when the size increases, dissociation is proper, dissociation is easy, and it will break into what? The corresponding the ions plus the OH minus ions, and as the result when we go down the group, we are seeing that yes, its basic character goes on increasing, isn't it? Now, when we talk about its stability, okay, and its thermal stability and its solubility, okay, we are seeing that as we go down the group, it goes on increasing, okay. And with reactivity of water, if we are seeing how do they react with water, we are seeing that yes, the reaction with water is fast in case of barium, and then strontium, and then calcium, and then magnesium. It means what? with the reaction of water, we are seeing that as we go down the group, the reaction of water with water, it increases. Okay. Now, coming to the halide character. Halide character means what? Some halogens are being added to this alkaline earth metals. Okay. So, here we are saying all will form the ionic bonds, all the halides like MgCl2. CaCl2, they all are forming what? Ionic bonds. Transfer of electrons are taking place. Exception is there of beryllium due to its anomalous behavior. It reacts with this halogens, but it forms what? Covalent bonds, forming what? BeCl2. And when we talk about this beryllium chloride, okay, if beryllium is reacting with chlorine, it will form what? BeCl2, that is beryllium chloride. Okay, and when we talk about this beryllium chloride beta, we are seeing that yes, in solid state, you can see a chain-like structure, totally beryllium, arranged in this pattern. Okay, here you are seeing that yes, the chlorine is being bridged between the beryllium atoms. Okay, so naturally here we are seeing that when in the solid state we get a chain-like structure. Okay, as shown over here. But here this is at normal temperature. Okay, it is at a chain-like structure. But yes, if we are increasing the temperature, okay, so what will happen? The bridge which has been formed, okay, what will happen? It will start becoming weak and it will start breaking, and thereby when the temperature is reached to 1200 Kelvin, what will happen? We will be seeing that now here a linear monomer has been formed, and in vapor state beryllium chloride occurs in a linear monomer form, okay, rather than the polymer form which was found in the solid state. Okay, here you are seeing that yes, this chloro bridge of these dimers are what will happen? They will break up to form the monomers. So in the solid state, beryllium chloride exists in a chain form, and in the vapor state you are seeing that yes, only linear monomers are present. Okay, when we talk about the bonding present, covalent in nature, isn't it? And yes, they do react with water, forming what? Beryllium hydroxide plus what? Hydrochloric acid. Okay, this beryllium chloride reacts with water, okay, provided the condition, forming beryllium hydroxide plus hydrogen chloride. Okay, now when we talk about the tendency to form the hydrates, these halides which are formed by the alkaline earth metals, okay, the hydrates, okay, as we go down the group, okay, the formation of hydrates decreases. Okay, so basically you can see that yes, magnesium can form, okay, magnesium chloride forms what? With 8H2O, it forms the hydrates. Okay, now here when we talk about this, the fluoride of this alkaline earth metals, okay, they are sprangly soluble in water. It means totally we can't see, it is not readily soluble, sprangly soluble. To an extent it is soluble, not readily soluble. Okay, solubility when we see, yes, it goes on increasing down the group, okay, in water. Like we will be seeing that yes, BaCl2 will be more soluble than strontium chloride, and this strontium chloride will be more soluble than calcium chloride, and so on, magnesium chloride we can see. And yes, the less solubility is of beryllium chloride. Okay, now let us study about the salts of the oxo acids. So beta, what are oxo acids? Okay, the acids consisting of oxygen. Okay, now here we can see that in this group 2, the elements, the salts of oxo acids, we will be studying carbonates, sulfates and nitrates. Okay, now let us start with the carbonates. Okay, having the formula what? CO3 2 minus. Okay, so the compound which will be formed by the alkaline earth metals, group 2 metals, okay, it is what? With the formula MCO3. Okay, if it is magnesium, MgCO3, calcium, CaCO3 and so on. Okay, and how it is prepared. Okay, let us see. Taking calcium as the example, calcium carbonate. Okay, so we will be taking what? This calcium hydroxide, CaOH whole twice, okay, and we will be passing what? Carbon dioxide. Okay, we will be getting what? Calcium carbonate, CaCO3 plus water. Okay, now when we see about the properties of the carbonates of the second group elements, okay, they are soluble in water. But yes, what do we see? Its solubility decreases with the increase in atomic number of the metal or the element of the second group. Okay, and that's why we are seeing that yes, barium carbonate, when we talk about, it is not soluble in water. Okay, when we talk about the action of heat on this metal carbonates, okay, the second group, what we see when this metal carbonates, when we heat it decomposes. And to what does it decompose? It forms the oxide. Okay, the corresponding oxide, like if it is MgCO3, if we heat it, we will be getting what? MgO plus carbon dioxide. General formula talking about that, MCO3, M for what? The alkaline earth metal, sorry. Okay, and we are heating it decomposes to what? The oxide, and carbon dioxide is released out. Now, when we talk about the thermal stability beta, it goes on increasing with the increase of cationic size. So, we are seeing that if the cationic size is increasing, the thermal stability is also increasing. So, which will have the most thermal stability? Okay, so we are seeing yes, down the group we are seeing about the thermal stability of the carbonate. It goes on increasing. So we are seeing that yes, if we talk about barium carbonate and compare it, barium carbonate and strontium carbonate, which will be more thermally stable, strontium carbonate rather than barium carbonate. Okay. Now coming to the sulfates. Okay, sulfates having the formula SO4 2 minus. Okay, so here in this, basically the formula which will be formed will be MSO4, M for the alkaline earth metals, okay, like magnesium, MgSO4, calcium, CaSO4, okay. Now how can we prepare it? Okay, for that preparation, suppose if we are preparing this calcium sulfate, okay, we will be taking what? We can take calcium, okay, and yes, we can add dilute sulfuric acid to it, okay, and when adding of dilute sulfuric acid, that is H2SO4, we are getting what? Calcium sulfate, okay, CaSO4 plus H2, okay. Now, you can see, can also prepare by, if you are taking calcium oxide, CaO, okay, plus H2SO4, you will again get what? CaSO4, and yes, along with that, here you will get water. In the first case you got hydrogen, second case when you are using the oxide of calcium, you are getting water. Yes, when you are using calcium carbonate, okay, and then adding H2SO4 to it, you will be getting what? Calcium sulfate plus water plus CO2. So remember this, if taking only calcium with dilute sulfuric acid, you are getting what? Calcium sulfate, hydrogen is given out. If you are taking oxide of that calcium and adding H2SO4, you are getting what? CaSO4, calcium sulfate plus water. And yes, if you are using calcium carbonate, okay, and adding H2SO4, you will get calcium sulfate plus water plus carbon dioxide. Okay, now when we talk about the stability, okay, to heat, they are stable to heat, okay, they are quite stable to heat, okay, they are stable on heating. In this, you can see that yes, when we talk about barium sulfate and magnesium sulfate, okay, they are soluble in water. Why they are soluble in water? Because their hydration enthalpies can overcome the lattice enthalpy, and as the result, they are soluble in water. We are seeing that yes, solubility goes on decreasing as we move down the group from calcium to barium, okay. Now, this beryllium and magnesium, when we talk about this, they are hydrates, okay, they form the hydrates, okay, by forming like beryllium sulfate and magnesium sulfate. We are saying beryllium sulfate, okay, adds up with 4 molecules of water, okay. Here magnesium sulfate, you can see 7, isn't it, molecules of water. So they can form hydrates, this beryllium and magnesium, forming the formula BeSO4.4H2O for magnesium, MgSO4.7H2. Okay. Now talking about the nitrates, how they are prepared. Okay, we will be taking alkaline earth metal carbonates, okay, and we will be adding dilute HNO3 to it. Okay, naturally now we are getting the nitrate of the corresponding alkaline earth metal. Okay, if we have taken this as magnesium carbonate, reacted it with dilute nitric acid, we will be getting magnesium nitrate plus water plus carbon dioxide. Okay, so on. So magnesium, if you will be seeing in this magnesium nitrate, okay, this magnesium crystallizes with 6 molecules of water. So magnesium nitrate, what happens, it adds up with 6 molecules of water, okay, and thus form the hydrate form. Okay, barium, and you will see that yes, in this it doesn't combine with water. Okay, they form completely anhydrous salts. Okay, and yes, we see that yes, these nitrates, okay, they decomposes on heating, okay, to give what? The corresponding oxide. And here you are seeing what? Nitrogen dioxide and oxygen is given out. Suppose if we have taken magnesium nitrate, we are heating it, you will get magnesium oxide plus nitrogen dioxide plus what? Oxygen. Okay, yes, now these nitrates, okay, they form hydrates, we are saying, but the formation of hydrates goes on decreasing as we move down the group, because we are seeing that yes, barium, okay, when we talk about barium nitrate, they are totally anhydrous in nature. Okay, they don't form hydrates. So we are seeing that yes, when we move down the group, the hydrate nature goes on decreasing. Okay, why they goes on decreasing? Because the size is increasing, isn't it? And yes, if the size is increasing, the hydration enthalpy is increasing, and thus what happens? The formation of hydrates goes on decreasing. Okay, so students, today we have studied about the alkaline earth metals, the group 2 metals. Okay, what we have studied? We have studied about the physical properties, the chemical properties, and the general characteristics of the compounds of second groups, as well as the salts of the oxo acids. Hope you might have understood. Good day, take care.